Hello everyone and welcome to this video. Put like in this, share with your friends needing for helping integral techniques. For today, we will solve these 4 exercises of integral using integrals by decomposition. This means that we have integral written as integral of f d of f, for example, f of x d of x, but we don't have how to solve directly this integral. That means using the direct integral techniques that we have learned until now. But if we analyze the f function, we can see that this f function can be rewritten in simple functions so that we can apply direct integral techniques that we have learned, which means, for example, f can be written as h plus g plus so on, and h, g, and so on are functions that we can take its direct integral into integration using the techniques that we have learned until now. So to this goal, we will solve these 4 exercises that we have here, beginning with the first one. A, I equal to integral of, can I see it's okay, 1 plus square root of x over x d of x. From here we don't have a direct technique that we can apply to solve this integral, but when we analyze the numerator of this integral, we can see that we have a sum of 2 terms, which is the first one 1 and the second one is square root of x, so that we can write this integral as 1 over x d of x plus integral of square root of x over x d of x. Now I will call the first part as I1 and the second part as I2. The first one, I1, is d of x over x, and we can see from here that we can apply the following rule. Integral of d of f over f is equal to ln of f plus c, so that I1 is equal to ln of x plus c, but plus c1 for here. Okay. On the other hand, the second term is integral of square root of x over x d of x, that we can write as square root of x over x square d of x, and this is equal to d of x over square root of x. To solve this exercise, we must remember that the derivative of square root of x is equal to d of x over 2 times square root of x, and from here we can write d of x over square root of x as equal to 2 times d of square root of x. Then we will substitute this term by this one, and I2 will be equal to 2 times integral of x. From here we can see that we can apply the following rule. Integral of d of f is equal to f plus c, and our integral I2 is equal to 2 times square root of x plus c2. Then the full I is equal to I1 plus I2, so that the solution is ln of x plus 2 times the square root of x plus c, where c here is c1 plus c2. We can show that this is actually the solution. So, if we take the derivative of f, we know that this derivative must be equal to the original function in our integral here, must be equal to 1 plus square root of x over x. And here we know that this is equal to ln of x plus 2 times square root of x plus c derivative. And for the first term, the derivative of ln function is equal to 1 over x, plus for the second term it's equal to 1 over square root of x, and for the derivative of of a constant it's equal to 0, so that we have here, and this is equal to, here we have square root of x, here we have x, and we get x plus square root of x over x square root of x, and we can multiply both by square root of x here, and we get x power 3 over 2 plus x over x squared, so that we have here x plus time 1 plus x power 1 over 2 over square root x squared, and simplifying 2 by this x, we have here 1 plus square root of x over x, which is actually the little f that we have in our original integral, this expression. Then this means that this is the solution for our problem. We go on solving the exercise B, which is 1 plus x. Okay. I is equal to integral of 1 plus x over 1 plus 9 x squared d of x. Again, here we don't have a direct technique to use or to apply to solve this integral, but again we can observe that the numerator of this function is a sum of 2 terms, so that we can rewrite this as 1 over 1 plus 9 x squared d of x plus integral of x over 1 plus 9 x squared d of x. And for the first again, I will call this as I1 and this as I2, so that For I1 I have d of x over 1 plus 3x, all of these square. And we can remember that if we have a rule which is integral of d of f over 1 plus f square, it's equal to arc tan of f plus arctan of f plus c. Plus c. This means that we can take 3x as our f function, and we can take its derivative so that we get 3 times d of x, so that d of x can be written as 1 over 3 d of 3x. And we will substitute this term by this one, and we have I1 has 1 over 3 times d of 3x over 1 plus 3x squared. And we have this integral fashion so that we can apply this technique, and we get 1 over 3 arc tan of 3x plus c1. We have the first part of the first term of our integral, and we must solve the second one, which is x which is x, okay, which is integral of x d of x over 1 plus 9x squared. Here we can see that the numerator is actually something has d of a constant a plus a constant alpha plus a constant beta. This time x square, or yes, x square. Now we can put out this beta, only we have here x square, so that, yeah, was correct, d of alpha plus beta x square, so that this derivative is actually 2 times beta x d of x, and we have x d of x has equal to 1 over 2 times beta d of alpha plus beta x squared. And if we we can see that if we take this as our alpha plus beta x squared function, then we have d of 1 plus 9x squared has equal, here alpha is equal to 1 and beta is equal to 9, so that we have then the result of this derivative has 2 times 9 x d of x, so that x d of x is equal to 18, 1 over 18 times d of 1 plus 9x squared. And we have now we have now I2 has equal to 1 over 18 integral of d of 1 plus 9x squared over 1 plus 9x squared. From here, then we must remember the following rule. Integral of d of f over f is equal to ln of f plus c. Then from here we can see that I2 is equal to 1 over 18 ln of 1 plus 9x squared plus c2, so that the full I is equal to I1 plus I2, which is equal to the first I, it's equal to 1 over 3 arctan of 3x plus the second term is equal to 1 over 18 ln of 1 plus 9x squared plus c. This is the solution for the second exercise. We can take the derivative of this function and we will see that actually this is the solution. Okay, we go on solving now the exercise C. Okay, C is I equal to 1 plus x over square root of 1 minus x squared d of x. And again, here we can see that we can rewrite this integral as integral of d of x over square root of 1 minus x squared plus integral of x d of x over 1 minus x squared. Here we have I1, here we have I2, so that I1 is equal to integral of d of x over 1 minus x squared. Here we can directly solve this integral using the following rule. Integral of d of f over square root of f 1 minus f squared is equal to arc sine of f plus c. And we have now I1 equal to arc sine of x plus c1. And for I2 we have integral of x d of x over 1 minus x squared. For here we can see also we can observe that again we can observe that the numerator is something associated with the derivative of the argument of this square root. This means if we take, for example, if we take now the derivative of 1 minus x squared, we get minus 2x d of x, so that x d of x can be written as 1 minus 1 over 2 d of 1 minus x squared, and we will substitute this term by this in our integral. We have now I2 equal to minus 1 over 2 integral of d of 1 minus x squared over 1 plus 1, or square root of 1 minus x squared. And it's possible to write, we can write this as 1 minus 1 over 2 integral of 1 minus x squared power 1 minus 1 over 2 d of 1 minus x squared. And from here we can see that we can apply the following rule. Integral of f power p d of f is equal to 1 over p plus 1 time f plus time f power p plus 1 plus c, so that for us, for this integral, our f is equal to 1 minus x squared and p is equal to minus 1 over 2. Okay, p plus 1, this is the rule. And for our exercise, f is equal to 1 minus x squared and p is equal to minus 1 over 2. We have now I2 equal to minus 1 over 2 time 1 over minus 1 over 2 plus 1 time 1 minus x squared power minus 1 over 2 plus 1 plus c2. And we have now here 2, we have here this is 1 over 2, so that we can simplify 2. This is 1 over 2, so that we can simplify 2 by 2 and we get minus 1 minus x squared. Here also we have 1 over 2, we have here 1 over 2 plus c2, or minus square root of 1 minus x squared plus c2, so that the full I will be equal to I1, I2, which is I1 is equal to where you arc sine of x, arc sine of x plus minus I2, which is minus 1 square root of 1 minus x squared plus c. This is the full solution for our exercise, and we can take its derivative to show that this is the solution for the exercise. Then we will follow in solving the last exercise, which is d I equal to okay, it's equal to integral of cos power 3 of x plus cos of x plus 1 over cos power 3 no, I think is power 2. Maybe here we have something wrong. Here must be power 2, yes. d of x. Okay, now we again observe that the numerator of this integral can be written as a sum of three terms. First is cos power 3x, the second one is cos of x, and the last one is 1. So that we can rewrite now this integral as integral of cos cube x over cos square x d of x plus cos of x over cos square x d of x plus 1 over cos square of x d of x. Now we have here I1, I2 and I3. For the first one is I1. We can see from there that it's actually cos of x d of x, and the rule is integral of cos of x d of x, of f d of f, it's equal to sine of f plus c. Then we have for I1 equal to sine of x plus c1. I2 it's equal to 1 over cos is d of x over cos of x, which is actually sec of x d of x, and this is equal to the rule for this, the rule for this is integral of sec of f d of f is equal to ln of module of sec of f plus tan of f plus c. This is the rule, so that I here it's equal to ln of sec of x plus tan of x plus c2. And for I3 we have where I3 is 1 over cos square, then it's d of x over cos square of x, which is sec square of x d of x. And to solve this, the rule is the following: integral of sec square of f d of f it's equal to tan of f plus c. Then we have now I3 has equal to tan of x plus c3, so that the full I, which is equal to I1 plus I2 plus I3, will be equal to I1, which is sine of x, plus I2, which is ln of module of sec of x plus tan of x plus I3, which is tan of x plus c plus c. This is the full solution for our last exercise for this video. Again, we was solving integrals by decomposition, which means that we had in our integral a function f that is so hard to solve directly. I mean, we don't have a direct technique to apply or to apply to solve our integral, but the function f is a function so that we can decompose in another simple functions. Function has h plus g plus so on, where integral of h can be solved directly or using the direct integration that we have learned until now. Also for g and so on. And for this goal we solved a set of 4 exercises as we saw in the beginning, and we get the solution of these 4 exercises applying the composition of integrals. Thank you for watching this video. Put like in this, subscribe in our channel, share this content with your friend needs for helping. Thank you. See you on the next video.